Hello everyone. I know it's the last one of this session. I will be very quick. I won't delay you too much. You pick up your lunch. Yeah, I'm Yatian, and I'm a PhD student in Huazhong Agricultural University in Wuhan, China. And also, I am a visiting PhD student in the University of Adelaide in Australia. And today, my topic is how do large neighborhoods attenuate overheating in Adelaide in megacity. And my presentation includes general context, literature review, and research question and my current research progress. And according to the report from Energy Sector Management Assistance Program, the world cities are heating up at twice the global average rate due to the combined influences of global warming and urban heat island effects. And also according to literature published in Nature Climate Change from our chair Zhao, it's a coincidence, but it's a very powerful evidence. By the end of this century, cities around the world could warm as much as 4 degrees on average, more than double the Paris Agreement's global of limiting global temperature rise to no more than 1.5 degree if green gas emission continue at high levels. Therefore, sustainable urban cooling is an urgent imperative. United Nations Environment Program proved that we urgently need sustainable cooling solutions through urban planning and design, both nature-based and the infrastructure-related, and energy-efficient building design, efficient cooling technologies and practice to keep our cities and the communities cool. And up to now, many cities have put forward their cooling strategy like cool neighborhood for New City and the strategy for cooling Singapore. And the blue infrastructure such as lakes, rivers, and reservoirs can effectively reduce the surface or air temperature due to its physical characteristics, including high thermal emission, low albedo, and small roughness. And therefore, utilizing blue infrastructure to enhance city breathability and create livable communities have been widely recognized as an important heat mitigation strategy to improve resilience to overheat. And because my study area is in China, so I would like to emphasize the climate policy in China at present. National Climate Change Adaptation Strategy 2035 also emphasizes the need to strengthen the construction of climate-friendly urban ecosystems and fully leverage the role of nature ecological spaces in improving urban microclimate. And through literature review, we found that the regulating abilities of water bodies in reducing air wall surface temperature of surrounding environments has been widely demonstrated. However, significant differences existed in water cooling intensities and cooling distances, so making it challenging to apply these scientific findings in highly heterogeneous and complex urban contexts. From this figure, we can see in different climate background and for different blue space type, the cooling intensity and the cooling distance is significantly varied. And the major impact of factors of water cooling effects include background climate characteristics, size and shape of water bodies and surrounding built-up environments. And in addition, differences in data sources like remote sensing and on-site measurements and the present time of air temperature bring additional uncertainties for scientific findings. So what is the core condition in revealing the cooling benefits of blue spaces? Firstly, we think we need to transform our research focus from blue infrastructure, from blue space itself to urban morphology in water surroundings because the blue space is different from the green space shared by Yatian because because the size and shape of water bodies cannot be changed, especially for large water bodies. But the urban morphology is the focus of urban spatial planning. So unveiling the synergistic effects of urban spatial form and water cooling performance, and establishing a co-development approach for both built-up areas and water bodies are crucial for bridging water cooling benefits into urban planning and design. And next, we think we need to transform our research paradigm of water cooling effects because from landscape purchase ecosystem functions to landscape purchase ecosystem process and ecosystem functions. Because in traditional research paradigm just quantify the static correlation between water characteristics and their cooling benefits, like to explore what size of what area of lakes can produce the best cooling effect. And in this research paradigm, the ecosystem process have become the key linkage between water patterns and cooling benefits. So exploring the dynamic interactions among urban morphology thermocirculation process, water cooling performance to reveal the internal driving mechanism is crucial for enhancing the applicability of scientific findings. So our research, the study area is in Wuhan city. It exhibits a humid subtropical monsoon climate characterized by high temperature and high frequency of calm winds in summer. And there are 166 so many lakes covering a total water area of 867 square kilometers. And with two main rivers converging in the city center, forming a unique waterfront urban spatial structure. But over the past few decades, urban expansion and densification has fueled a number of water bodies that dense high-rise building clusters have disrupted the connection between rivers and lakes, leading to the worsening climate environment. So in summary, the abundant water resources of Wuhan city and its worse climate environment form a distinct comparison. So our research is to use the weather research and forecasting model to explore the diurnal development and the spatial structures of lake breeze circulations, and as well as the impact of large lakes on the intensity and the spatial variation of air temperatures and the wind environment, and especially under high temperature and wet wind weather conditions. And based on results, we put forward some planning strategies for incorporating lake cooling effects and the heat mitigation strategy. And the papers were published in landscape and urban planning, sustainable cities and society respectively. And the first paper is how to use lake breeze circulations to improve urban natural. And we use the Wolf model comes with four-level elastic grid system, and the innermost grid system covers the full area of Wuhan metropolitan development area. And we all know Wolf model comes with two types of land-use data sets, including USGS and MODIS. But these land-use data sets cannot accurately reflect the current in-progress census in the context of rapid urbanization in China. So we use the land-use data from Gongpeng's research group in Tsinghua University in the innermost domain with the spatial resolution of 10 meters. And then we divided the in-progress census into three categories for better representing urban spatial and morphology. And finally, we selected 5 further stations to evaluate the accuracy of work simulation. The evaluating results is positive. And we calculated the occurrence frequencies of lake breeze, and results indicated that large lakes with simple shape and aggregated distribution were more likely to develop and sustain lake breeze. And from the figure on the right, we can see the darker the blue color, the greater the deflection angle around lakes. So we found that lake breeze occurred most in the morning, peaked around noon, and dissipated in the afternoon. And through the analysis of lake breeze circulation, we found that there were distinct LBC flow regimes on different lake shores, in which the perturbed LBC, mainly on leeward lake shores, increased the cool air penetrability compared with the strong LBC predominantly on windward lake shores. And in the boundary layer, chain flows of LBC formed over the lake groups. At the upper level, outflows from one upwind LBC were connected to the lower level inflows from the other downwind LBC. And according to these results, we propose a conceptual framework for planning urban blue space to enhance nature-wide recognition through 3 elements of landscape patterns, including patch, matrix, and corridor, and a series of planning strategies which can support urban planners to create livable built environment with lake breeze entry. And the next work is well on how to cross through blue infrastructure, and in this work, we conducted sensitivity experiments using the Wolf model to explore the intensity and the spatial variation of air temperatures and wind fields influenced by lake groups located in downtown areas, inner suburbs, and outer suburbs. Under typical heat wave conditions in Wuhan, also it was analyzed how lake land energy exchange and LBCS regulates the cooling effects of large neighborhoods. Comparing the cooling effects between downtown and suburban neighborhoods, we found that downtown neighborhoods exhibit higher cooling intensities than suburban neighborhoods with similar size, and upwind neighborhoods could more built-up areas than those in downwind side. And also, downtown neighborhoods showing greater differences in sensible heat flows and lower differences in latent flows. And LBCS promoted the spreading of cooling effects in both horizontal and vertical directions. And according to these findings, we summarize the temporal and the spatial heterogeneity in the neck cooling effects, and also how the neck breeze flow between neck and built-up areas, and also inside the city center. And according to these findings, it was proposed a conceptual framework that prioritized neck cooling effects as a strategy to mitigate overheating from conditional analysis, land-use planning, and the development control three aspects. Yeah, this is all about my presentation. Thanks very much.
Questions?
Thank you for an interesting report. It is a good idea, cooling by blue surface. But as far as I remember, 15 or 20 years ago, in Ikuk, the fifth of the sex, our colleagues from South Korea reported that one river in Seoul was covered by road, became underground, and they spent a huge money to reopen it, to reopen this urban air for the cooling. They replaced a road. They spent many millions of dollars. And when they reopened this river, the cooling effect was limited by a very small distance. I don't remember exactly, maybe 50 or 100 meters from the coast, not larger.
Mm-hmm.
What is your opinion?
Mm-hmm.
Is it so small effect in space?
Yes.
Or not?
Yes. Thanks so much for your interesting question. Yeah, it could be explained by the different size of blue space, because our research focus is kind of the large blue space. They are not affected by urban expansion and densification. Yes, and their size is about like 15 square kilometers to 200 square kilometers. So our focus is kind of large neighborhoods. It's not affected by rapid urbanization in the context of urban expansion in China. Yes, thank you.
All right, thank you everyone for coming, and let's give another round of applause to all our speakers and volunteers. Thank you. See you next week.